So in part B, we found where h has a horizontal tangent line. We've also found where h could potentially have a min or a max. What I'm going to do is take these two numbers, really, negative square root of 2 and positive square root of 2, and test numbers in between, as well as off to the sides of each of these, into the derivative to see if the derivative is positive or negative on those intervals. Now, the other trick is that if x is 0, the derivative is not defined. So we also need to consider, well, what if x is 0? So I'm going to plot 0 on the number line to make another interval that needs to be tested. If I test a convenient number from this interval, I could use like -2, for instance, because square root of 2 is about 1.4. So testing -2 is going to be to the left of -1.4. Plugging -2 into the derivative gives me 4 minus 2 on top, and -2 on the bottom gives me a negative result. I'm going to put a little negative there to signify that. For this interval, I can test something like -1, because -1 is between 0 and -1.4. Plugging -1 into the derivative gives me 1 minus 2 over -1, which is a positive result. Testing this interval, a representative number would be like +1. I'm going to plug 1 into the derivative. I would get 1 minus 2 over +1, which is again a negative result. So these numbers that we're picking actually represent any number you'd find on their interval. Something from this interval, a simple number to use would be +2, because that is to the right of 1.4. Plugging in 2 to the derivative gives us 4 minus 2 over 2, which is a +1 and a positive result. With all that now, we've got this visual to help us. We can say the graph is, because the derivative's negative, the graph's decreasing here and increasing here where the derivative's positive. The graph is also decreasing here and increasing here because we change from a negative derivative to a positive derivative, means the graph changes from decreasing to increasing. I don't really have enough room to write it, but if I did, I would say that negative square root of 2, x equals negative square root of 2 yields a minimum, and x equals positive square root of 2 yields a minimum, because at each of those points, h prime changes from a negative value to a positive value.